Evaporation occurs over an open container or a body of liquid. So let's suppose we have a liquid here. We might consider it to be water, but it could really be any liquid. And this container is open to the atmosphere. You just learned about vapor pressure. And in vapor pressure built up in a closed container because some of the liquid would escape up into the vapor phase. And this vapor pressure built up when we got an equilibrium between liquid going into the vapor and vapor going back into the liquid. But now in evaporation, with our container being open, it's not going to return. So if a few molecules at the liquid escape, we have due to vapor pressure, we then have some liquid molecules escape due to their vapor pressure. Now, the liquid molecules that escape are going to be the ones with the highest average kinetic energy. The ones that escape will have the highest kinetic energy. So if the ones with the most kinetic energy leave, what happens to the average kinetic energy of the ones left behind? And that is that average goes down because the highest energy ones escape. You may remember from our study of gases that average kinetic energy is proportional to temperature. And so when the average kinetic energy is lowered, it is essentially cooled. This is why evaporation can cool a liquid. But now when this liquid cools and its temperature drops slightly, what's going to happen is that heat will come in from the surroundings. And when heat comes in from the surroundings to maintain the temperature, the temperature will be maintained and it will continue to evaporate. That heat going in makes evaporation endothermic. So hopefully that gives you a little better idea of how evaporation works.